Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over isotopes. So what are isotopes? Isotopes are simply atoms of the same element that differ in the amount of mass that they have. So in other words, these are atoms that have the same number of protons because protons determine the element identity, right? So all nitrogen atoms are going to have a certain number of protons, like five, and carbon's going to have a certain number of protons, six, and so on. So the same element, meaning same number of protons, but they're going to differ in the mass. And so the only other particle that is going to contribute mainly to the mass of the atom is the neutron. Electrons are so small comparatively that we kind of ignore them as far as the mass of the atom goes. So all we really care about as far as mass is going to be the protons and the neutrons. Since the protons don't change for the element, it's got to be the neutrons that change, and therefore is going to determine the mass of that particular atom, of that particular element, right? So let's get into this. So here I have three atoms of carbon. They are all atoms of carbon because they have six protons. So protons are in red. I don't know if you can see it well enough on the video, but I have six red dots here. I have six red dots here, and I have six red dots here. So they are all the same elements. They are all carbon atoms. But you'll notice that the blue dot is neutrons. So if you count the blue dots here, you'll get six neutrons. Here we have seven neutrons, and here we have eight neutrons. So this is the lightest form or lightest isotope of carbon. This is the next lightest or next heaviest, I should say, of carbon. And this is the heaviest isotope of carbon. So we got three different isotopes, right, of carbon because they are all the same type of atom. They're all carbon atoms, but they differ in the mass because they change the number of neutrons. So one of the things we got to know to determine the number of neutrons you might have in your element or in your atom is the mass number. So the mass number is defined as the number of protons and the number of neutrons. And why is it called the mass number? Because as I said, the mass of the atom is by large, almost all the mass of the atom is concentrated in the nucleus. What two particles make up the nucleus? That would be your protons and your neutrons. And so therefore, the mass number is going to be equal to the number of protons you have plus the number of neutrons. And then we have our atomic number. The atomic number I should write down is equal to the number of protons. The atomic number is equal to the number of protons. And again, the atomic number is the big number that is over and above the symbol on your periodic table. So if I show you really quick my periodic table, so you'll see here that top number there right above the copper. So that's 29. So copper has an atomic number of 29. Zinc here is 30. And then if we look at carbon over here, right over here is 6, right above the C there. So the numbers on the top are the numbers that are called the atomic numbers. And that atomic number tells you the number of protons. So if we were to write our isotope symbol, we would have first this X represents the symbol of the ion. So whatever the symbol of the element is, that's where you would put here the X. So for carbon, it would C. it would be C, capital C. If it was nitrogen, it would be capital N. If it was neon, it would be capital N, small e, and so on. So you'd have your symbol here. And then at the top left corner of the symbol, that's where your mass number would be. And so we represent the mass number by the letter, capital letter A. And then down here in the bottom left corner, this is where we would put the atomic number. And so they use the capital letter Z for the atomic number. So that would be the number of protons. This would be the number of protons and neutrons. And then let me add that up here, you would have charge. If there's a charge, then it would be plus or minus. So on this top right corner would be your charge if you have charge. If you have an ion, then that's where you would put the charge in the symbol for that ion. Okay, but we're talking about isotopes. We're not talking about ions in this video. Okay, so we have our three isotopes of carbon, and what I have written down below here is the natural abundance of each of these isotopes. The natural abundance is basically how much out of all of the carbon atoms in nature, how much is going to be this isotope, how much is going to be this isotope with the 7 neutrons, how many is it going to be this isotope with the 8 neutrons, and so on. And what we find is that by large, most of the isotopes of carbon, it has 6 protons and 6 neutrons. They have 6 neutrons, so it's like 98.93% of all the carbon atoms we find in nature have 6 neutrons in the nucleus. And then the other amount, so the isotope of carbon that has 7 neutrons, that takes up 1.0% of the total amount. And then this carbon isotope has 8 neutrons. This is by far the least abundant in nature. And so it is 1 ppt. PPT stands for parts per trillion. So ppm would be parts per million. ppb would be parts per billion, but this is parts per trillion. So 1 out of every trillion carbon atoms is going to have 8 neutrons. So that's not a lot. Okay, so you can calculate the mass number of each of these isotopes by adding together the protons and neutrons. So the mass number for this one is going to be 6 protons plus 6 neutrons equals 12. And then for this isotope here, the mass number is going to be 6 protons plus 7 neutrons. So the mass number is 13. And then the mass number for this isotope is going to be 6 protons plus 8 neutrons, give us 14. So when we write our symbol for this carbon isotope, it's going to have the 6 on the bottom, right? So all of these are the symbols of the isotopes, and you'll notice that the bottom number is the atomic number. The atomic number is the number of the element on the periodic table, which indicates the number of protons. So since these are all carbon, we put C for the element symbol, and of course, they all must have 6 protons because carbon has 6 protons. If it wasn't carbon, it wouldn't have 6 protons. So each of these symbols has a 6, but the top number is the mass number. And the mass number is going to differ because they differ in the number of neutrons. So this isotope has a 12 as a mass number. This one has a 13, and this one has a 14. So the way we would name these isotopes would be in the following way. I can write the name of the symbol followed by a dash and the mass number. So this isotope here is called carbon 12. We can shorten that and just put the symbol and then dash 12. So C12 or carbon 12. That would be the name of this isotope. Here, this isotope has a mass number of 13 that we calculated here. So we would call this carbon 13 or C13. And then finally, this isotope of carbon has 14, a mass number of 14. So we call that carbon 14 or C14. So, and this is how you would write the symbols for your isotopes, and this would be how you would name them. So either carbon 12 or C12, carbon 13 or C13, and so on. So that's it for this video. I hope you enjoyed this video. If you did, then please like and share the video. Hit that like button over there. Subscribe to my channel. And when you do, please hit the notification bell so that way you can be notified by all the videos. Make sure you click all. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you want me to cover a certain topic in a future video, then please let me know. I would love to do that for you. Thanks for joining me and have a great day.